First, I apologize. I missed Tuesday's class because I had a board meeting up in Lake Placid. Actually, I went to North Pole, New York. But I asked you guys to do some of the questions, okay? We will have some discussions today, okay? To make up the office hours on Tuesday, so I'm going to extend office hours today from 2 to 3:30. If you guys have any questions, you can come during that time. You don't have to make an appointment with me. Right? 2 o'clock to 3:30, so you can just come to my office, which is the BC 160A. I'm actually I will send you guys email. I'm going to move Thursday mornings office hours to Wednesday afternoon. So that, because some people I know, a lot of you guys have classes right after, when it's not working for you. So I still keep the option on Tuesday, 10:45 to 12, and then Wednesday, 12 o'clock to like 1:30. Right? So I think maybe different times, maybe working for more of you guys. But if those times still don't work for you, just email me. Let's make an appointment. Okay? Any questions? Right. So last lecture we did some introduction about ecology. Right. Give you some examples of invasive species. So what is invasive species?
A non-native species that goes into a different environment and then causes a negative effect on that environment.
Okay, so non-native, right, to that area, and then pose some threats, right, dangers to that ecosystem. Okay, so make sure you have those 2 points. So the invasive species, we talked about the origin of the zebra mussels, where they are, how they actually transfer different things. You don't have to know the details, okay, but just to know what ecology covers. What is this part of the ecological study or not? Then we give you some data, right, looking at the water quality index. For example, the chlorophyll A amount of algae, and we see it's decreasing, right? And then with Saki depths, water clarity, we see increase. And we can see the trend and say yes, but we want to quantify it, right? So if you want to quantify it, we have to use some statistics. We say, hey, this is a good trend that is increased, but how are you going to say it? People do not trust their words. They say, hey, see, look at it, it's going up, right? This is going down as a trend. But is this trend significant or not? You have to use the data, quantification to show them, convince people, say, hey, yes, this is absolute trend, this is happening, right? So in this week's lab, we did and will do one section already did yesterday, and then one section we'll do it on Friday, looking at the statistics. You guys will collect some of the data points and then try to analyze it. Okay, try to compare the sample mean and the population mean. Try to see if it's accurate to use sample represent the population. Okay, we're going to have more discussions later on. Now we continue the ecology study, looking at the introduction part. So what is ecology? Right? Some people worry that, hey, you leave the blanks on the PowerPoint. I cannot finish it. Don't worry, right? Sometimes I just leave it blank because I want you guys to think about it, want you guys fill the blanks, right? But I will also fill the blanks as well. So by now, what would you think? Ecology is what? Yes, sir.
Relationship between living organisms and the environment.
To study the relationships with the organisms and with the environment. I think this is the kind of like the second part is here, right? Ecology is the scientific study of relationship of organisms with one another and with the physical chemical environment. Or we can say what? Replace the word relationship.
Interaction.
Interactions, yes. So we can say interactions or relationship, the both are okay, right? Perfectly fine. So there is another ecology definition. Ecology is the scientific study of the abundance and distribution of organisms and their interactions with the environment, okay? I'm going to repeat that again. Ecology is the scientific study of abundance and distributions of organisms. So we study their distribution. Where are they? How big they are, right? Abundance. How many of them there are, right? So the distribution of abundance of organisms, or you can say the abundance of the distribution, doesn't matter, right? And the interactions determine distribution and abundance. Determine the interactions that determine the distribution and abundance. Okay. So it's the same thing, like you see what the factors is going to affect their distribution and abundance. Those factors will be the interactions, right? How between the organisms and the interactions between the environment and organism. Did you guys all report down the definition? Fill the blank? Yes? Okay. I repeat one more time. Ecology is the scientific study of the distribution and abundance of organisms and the interactions that determine distribution and abundance. So the two definitions have slightly differences, but they both are okay, okay? If I list ecology in the definition as you try to define it, you can use either of them, right? But the main point is to study the relationship, study the interactions, right? Both of them talking about the interactions, the relationships, okay? And we already talked about those interactions. What can be? If your favorite animal, what is your favorite animal? Dog. Dog. Okay. So because dog mostly is in the house, so let's see wolf. Okay, a similar one. So let's say you want to study the wolf in that particular mountain. What other interactions can affect or interact with the wolf?
What the
Food source.
Food source, right? What do you mean food source?
I mean, they gotta eat, so like, let's say
Some other
animal
small animals,
that they prey on.
right? Maybe there's hunters to hunt it as well, right? So you have predation, prey, relationship, interactions. What else? Yes? Climate, good. So the climate, is it too cold or if it's too hot, that's going to impact them as well, right?
Landscape.
Landscape, be a little bit specific.
Like the habitat.
The habitat, some maybe they live in cages, or they're there. If there's no cages, they probably have to move somewhere else, right? So that's kind of habitat. So there are a lot of interactions, no, and maybe some disease, right? Parasitism, right? Competition for food, maybe some other I don't know, maybe coyotes or something there, right? They can compete for some of other food with it. Pollution, availability of water, disease, climate, all those things can have impact on this population of the wolf. And here we study ecology in different scales, right? In different scales. So in your textbook by 122, you will see a lot of them starting from by 122, looking at as biology. A lot of them from here, molecular stuff like 122, 123. You guys study, right? Cells, tissues. Then we're gonna move to here, which is ecological study, right? Ecological study. We study organism, population, community, ecosystem, biosphere. So I ask you guys to definitely know the difference between those three scales: population level, community level, and ecosystem level. Again, so here a specific example of zebra mussel. No, about zebra. So zebra, here you're looking at individuals, right? You look at the population. So there are a bunch of zebras. And then there's community, right? So you have zebra, giraffe there together, and then maybe there's some elephants over there. So here we have ecosystem, right? In the savanna, we have all those grass, the suns, the desert, all different things that mix together, right? The higher level is the biosphere, looking at the whole climate change. Now people are looking at a larger scale to try to see how the climate change actually impact those things. Different levels of organism ecological study. We have the individual level, as you can see at the organisms, right? And the local population is the group of individuals from the same species, right? So we already defined it as before. The community is everybody. Do I have to repeat it? The local population. What is the population? Or you know it? Yeah, same species live in the same area. Okay, community is all the local populations. That means different species, right? Different species. Okay, now ecosystem is the community, right? All those different species, they interact with the environment. So the environment can be biological or can be non-biological, right? So those are physical, chemical environment that include is everything over there. So the ecosystem study, okay, so it's different levels. Biosphere is everything on Earth, right? Everything on Earth. Okay, so but if somebody wants to study something in Mars, that's perfectly fine too, okay? But we haven't found anything there yet. Any questions? Ecological study levels? Yes?
Can you just explain the difference between like a community and ecosystem?
Okay, so a community looking at only organisms, right? So ecosystem includes those non-living things. So that's the major difference. When we say, okay, I want to study the maple trees and the oak trees on campus, I study what? At what level?
Community. Community.
Depends if you're studying like all one species or like different species of oak trees.
I said I study maple trees and oak trees.
So
So that is community, right? So I want to study the North Branch. There's a forest behind the sports center, right? There's a lot of trees over there. I want to study the forest there. So that's probably ecosystem because that forest has low soil, has all those air, chemistry, pollution, so all those different kinds of things there. Any question? All right. Now again, so this one looking at the different things is similar what we talked about, right? One thing is a little bit different is molecular level. We do use molecular techniques sometimes, but not all the time, right? You guys probably, some of you interested in studying cell biology or cancer research or genetics, right? Using molecular techniques. For ecologists, sometimes we do use molecular techniques, try to trace their evolution. I try to see what they change. That's kind of study at that level. How they're going to associate with different species, how they actually evolve. Alright, so here looking at how they're going to affect the environment, right? How the environment affecting those individuals, and looking at the population, looking at the trend dynamics of the population. If you like the wolf, you want to see how they change. Do they become a nuisance? There are too many of them, killing all those animals around it, or they're threatened, endangered, right? So those are the things we can see, the dynamics of the population. We want to study what are the factors actually impact those dynamics. Is that predation? Is that because of the hunting, or because of the lack of food resource, or because of the disease spread? Community level, looking at the composition structure of the ecological community. This place we most of study the interactions, looking at the predation-prey relationship, competition relationship, or mutualism, right, or biosynthesis. Those are different things together. All right, ecosystem, looking at the communities, how they impact, how to affect the environment, how the environment actually changes, right? Biosphere, looking at a much larger scale, looking at the climate change. So just give you some background about the ecological study at different levels. So what do ecologists actually study, right? What are the things they're going to study? So ecology is a pure and applied science. What does this mean is that it's a pure science, is more, sometimes it's theoretical, there are those theories, right? There's theories, there's some models kind of looking at these things. Applied science means you can use the knowledge we actually can apply to our real life, right? So for example, you have those burned forest, right? This is actually part of the, we say prescribed burning. That's part of the forest management, because you actually burn the forest on purpose, actually make the regeneration of the forest much better. Next, we want to, how are we going to study those signs, right? So there's some methods, right? Observations, monitoring. So one of my research is looking at the Park River water quality. We always monitoring just to see every year, every month, collecting water samples, measure it, and to see if there's big changes every time, right? You guys are part of the research as well, looking at the water quality. You're going to do some of the experiments throughout this semester, and then collecting data, try to see if there's differences or not. Sometimes we do mesocosm experiment, which means a small, medium level, medium size of the experiment. You actually do it like a manipulative field experiment. You go to the lakes, go to the rivers, go to the towns, and go to the forest. You set up those experiments, right? And then doing it over there. It's kind of control, but it's not exactly the control. For example, if you want to study how the fencing, the herbivory is going to affect the grass, right? So you do experiment. You put the fencing in some part of the grassland, some part like leave it open. So just let the moss or something, so those herbivores come in and then try to eat those grass to see how they're going to impact those things. So there are some studies doing in some like Yellowstone National Park to see those moose and those elk, how they impact the grass. Controlled lab experiment, that's called a microcosm. That's much smaller scale. You can do it in a greenhouse. You can do it in a growth chamber, right? See how the light is impact or how the pollution is impacting the growth of those plants. Quantitative models and statistics. So this one using data and then create some of the models to have predictions, right? Sometimes you can see the climate. Okay, what happens if the temperature increases 1 Celsius degree? What's going to happen to the sea levels, right? How many of the cities will be under sea? All those are kind of like a quantitative models to show this. Questions? All right, now this is a review where we discuss, I emailed you, try to looking at this. So you guys all take 122 before, study hypothesis. How many of you haven't learned hypothesis testing before? So nobody, so you guys all know how to do it, right? Okay, good. So here I said water becomes clear after deep mussel invasion in this particular lake, Oneida Lake in New York, right? So you want to see what is your hypothesis. So you have the hypothesis, you have the observation. You see it and then make you think, right? Ask the question, why? And then you're going to propose a educated guess to explain why, right? So your educated guess is the hypothesis, right? Is the hypothesis. So what is yours? What is your hypothesis to this? I give you a couple minutes to share your answers with your neighbors, okay, 2, 3 people, try to form a group, see how you guys agree with each other, okay?
Went in there, alright. Kind of not much at all. I just said if the water quality decreases from the presence of deeper mussels that is located on the pond, we'll be able to photosynthesize at very depth. And explains how to study that so but I did not really write too much because I didn't want to write like a 3 or 2 pages and have them be like, but looks like you got it done. Am I have to read it?
I might not make that much sense.
What is that?
Or you would still think
Yeah, we have to do it.
When do you have
Wednesday.
Oh, so you just had left.
Yeah. What about you?
I have one.
It's hard. It's hard.
Right after we had?
Yes. It's easy to collect the data, but it has so many steps you have to do it. And after you collect the data, you have to do the graph. Yes, and you have to do so many math.
Keep slow in this class. I feel like we just keep talking about the same thing. Back to the environmental.
I'm a sophomore. You? really?
I just transferred from my university to Hartford, so I have like 12 credits left to take, but a few prereq things that I had to get out of the way, so here I am back in college. I feel like I've taken this class like 12 times with my marine ecology and then transfer over to pre-ecology, so it's a little different.
I mean, yes, it's so strict more.
Are you going to
You are the third person on there.
Oh yeah. Is this a rain?
Oh, sorry.
Yeah, I know. They tell me to go.
Alright, can anyone share with the whole class what you guys discussed? Do you guys agree with each other?
Yes.
Yes, you do agree with each other. Okay, let me see. What do you agree on? Yes, correct.
Do you just want me to read it, or do you want me to just like generalize?
Just say the hypothesis.
Oh,
either
okay.
way.
I said if zebra mussels are introduced to a new environment, then it is likely the waters will increase in clarity due to the mussels' high rate of filtration in order to consume nutrients.
Okay, that's a very detailed. And anyone else? Anyone else?
I mean, it's like the same thing that she just said.
Go ahead.
I said it was predicted that the water became clear due to the zebra mussels eating the algae population presented in the lake.
Okay, because they're eating the algae, because their filtration rate is high. Okay, good. I think you guys all agree with this. Alright, so next step we're going to talk about the experiment design. Okay, so when you have experiment design, you will have to have control group and treatment group. So you compare them, then you can see the difference between those two groups, right? When you set up the control group and the treatment group, everything should be the same except what? Independent variable. Okay, what is the independent variable? The things you are manipulating, which in this case will be the water,
Zebra mussels.
we are manipulating.
Water quality, right?
Are we manipulating water quality? What are we testing? What are we measuring?
Zebra mussels.
We are measuring zebra mussels? We are measuring what? Yes.
So the dependent, what we're measuring is the water clarity. So the independent, which we are introducing, is the zebra mussels being in the water, correct?
Okay. Yeah, that's your opinion. Okay. Anyone else? You have a different opinion? Yeah? Yes.
One week we kind of need to the concentration or the density more or less, because if
Density of what?
the lake water.
The lake water. Okay, so we're gonna control the density of the water and to do what?
To see, because I believe the water being more dense if it's more clouded by pollution or by algae. So when we introduce the zebra mussels, it's gonna cause density to go down and probably return to like close to like what a normal lake would be like prior.
So you want to look at it, right? So you want to see if the zebra mussel has the impact on the water effects, okay? But how are you going to say can see the water different? Are you put different levels of water and then which one you want to put the zebra mussels in? All of them. Same zebra mussels? Yes, and then to see, I got you. And then see maybe some of them become clear, some do not.
Well, for my control in my experiment, they were just gonna have zebra mussels in a freshwater lake, because I know it's not gonna really cause a change, but just but that's what you really. That's sort of like the idea of like what you're really trying to get the other lakes to be like. So like if, and and the other experimental ones are one clouded by algae and one clouded by human pollution, because it didn't really specify what, the picture to me didn't specify what was clouding the water before.
Okay, good. Now we hear two different answers here, right? So one says we are going to manipulate the absence or presence of zebra mussels, or the different quantities, densities of mussels. The other says we are going to manipulate the different cloudiness of water, right? And then doing the experiment at the same amount of zebra mussel in it. So what do you think? Which one is right? I think these are two really opposite. So there's a dependent variable and the independent variable. They are opposite in these two answers. So it seems like there must be one answer is right. You still want to defend your answer?
No,
Just a
I was,
second. Okay,
it's
go ahead.
just the second one, like, the second experiment you're explaining, like, although you're gonna see a change happening, I mean, you're trying to see if the presence of zebra mussels is going to do anything to the water. So if zebra mussels are in all the tanks, you're not necessarily having one control to test if the zebra mussels themselves are the thing changing the water. So you're gonna have to have a tank with nothing in it in order to determine, like, okay, so it is the zebra mussels doing this.
What do you think? So what she says is that you will see, you're going to expect to see all the water tanks has become clear, right? Do you agree?
Yeah.
So you have a little bit of algae, medium amount of algae, a lot of algae, and then you put the same amount of mussel in it, and then you will expect to see what? Clear, clear, clear. Everything is more clear. So is that because of the mussels? You don't see the differences. You don't have control group and the treatment group. Okay? So we actually manipulate the mussel densities. Okay? If you either absence or presence or different gradient levels. Right? So now I'm saying your answer is right. Okay? Because I want you guys have, different answers, try to have discussions. Through the discussions, you will probably try to emphasize your learning, okay? So you can learn better, get answers. Usually I will not tell you right away, say, hey, yes, you're right. All right, any questions? So the independent variable is what? What?
The absence of
the absence, presence of the mussels, right? And the dependent variable, the measurement will be the measurement. What do we are measurement? What we are going to measure? What we are going to testing? Water quality. You want to see if it's clear or not. Right? We want to see clear or not. All right. Any questions? Okay, good. So make sure you have it. Right? If you have your answers, make sure you have your name and then pass it to me. Don't worry. I just want you guys to think. I'm not going to put a lot of weight in the correctness of your answer. I know some of you guys got it wrong. That's perfectly fine. Okay. Yes.
I just emailed it to him. I didn't print
Okay.
it.
Fine. All right. Okay, I'm gonna collect it. Thank you. So I hope you guys through this exercise, you know what the experiment design is. In the lab, there's one question actually ask you what is those things. We'll see how that goes in one of the questions in the lab. Okay. So here is one of the experiments that they tried to looking at what contributed to algal bloom. So why some of the ponds, lakes have so many algae? What is the cause? Some people say it's the nitrogen, some people say phosphorus, some people say other different things, right? So this guy did an experiment, the lakes experiment. They separated the lakes, right, into different parts. So one, they add a lot of phosphate in it, so which have a lot of like in fertilizer. So they have a lot of fertilizer. It has phosphate in it. So they put it over there. See, and this one doesn't have any of those extra phosphate. You will see the differences, right? So this one have a lot of algae. So in this case, what is control? This part without phosphate addition, that part is the treatment group, right? And what is the dependent variable? Dependent variable?
Growth of algae.
Algal bloom, amount of algae, right? And the independent variable?
Phosphorus.
Phosphate amount, right? Or sometimes you can put the absence and presence, but sometimes you can introduce a gradient of levels, okay, or the concentrations. For example, you have tiny bit phosphate, zero phosphate, tiny bit, medium amount, a large amount. So you can have different levels, not necessarily just the two. All right. So this the first course we want to you guys understand the course policies, right? What is ecology and what are the contents we discussed in this course, and get familiar with the case study of the deep muscles. Okay, know something about it and know the hypothesis testing. Any questions? All right, next I'm going to introduce you the statistics, right? What it is, so what is the statistics we have here? This graph shows you some normal distribution of those data. So what do? Is that you collect a bunch of the data, a large amount of the data points, and then you're going to create the graph, like we call it a histogram. This actually are the histogram, but you ignore those bars, now become the curve, right? So what you can see here, most of the data is concentrated in the center, right? A lot of them are in the middle of them, and then you have some of them like a smaller amount in the tail, okay? Smaller amount, the larger numbers in the tail, and then maybe you have an outlier, we call it, right? So it's outside of the curve because it's unusual, right? And then maybe there's an outlier, bigger number too. So the statistics we want to learn in this course, we just introduce you some of the basics, right? You want to use the data to interpret the graph and then make scientific conclusions, right? This one we discussed in last class, ecological levels, how to study ecology, looking at the deep muscles. For statistics, I'd like you know the basic terms. What is population? Which everyone should know by now, right? Sample, mean, median, mode, sample size, standard deviations, all those kind of basic statistic term I want you to know. How to calculate the mean, median, and the mode, and how understand the distribution patterns. So some of the distribution is the normal distribution, symmetric, or it is non-symmetric. Maybe they have two peaks, okay? Maybe they skewed to the right, or maybe they skewed to the left, right? So there's a different things you needed to talk about. Understand the distribution patterns, right? How to create a histogram, which it will show the distribution. and then using the histogram to calculate the sample size, mean, median, mode, all those things. Okay? So what first I want to talk about is why do we need statistics? Right? Why do we need to get the statistics? If you want to know the medicine is effective or not, right? You say, hey, I just developed a new medicine. I think it's the best one in the world. It's going to cure every cancer, right? How are you going to prove it? Are you going to prove to cure, give everyone a medicine, your medicine, try to see if they're going to work or not? You can't, right? You do not have those energies, you do not have the money to give them. And also there's regulations limit you, you cannot do that, right? The policies and stuff. So sometimes you have to do only small samples, right? So just go treat, maybe 4 or 5 people to see how they're going to respond to your new drug, right? Try to see if it's going to better or if it's worse. So that's the thing. Sometimes, there's not enough time, energy, no technique, those technologies. For example, if we want to study the wolf in the forest, I want to look at, okay, how many of the wolf are there? What are we going to do? Using everybody have the net to go there, catch the wolf or no? No? That's hard, right? Always do a survey, mail them, say fill it out, mail it back to us. We cannot do that either, right? So what we do, we try to maybe do something called a catch release, right? And catch them, release, and then try to calculate them using statistics, try to estimate the population size. So those are the things we can do. You guys can, using the statistics, become more critical thinking and have the analytical skills, right? And try to interpret the data, right? The data. Because some statistics will help you to understand if it's good or not. For researcher and for consumer, as a consumer, in the label of different things that we'll talk about, like a drug, sometimes they will say how much, there's a report saying how much effective. It's like a 60%, or if it's 80%, which one would try? 80% effective, right? Maybe it's not effective to you at all. But for a larger population, 80% of them has positive impact. So you probably want to choose that one. Although maybe you are good with the 60% ones, but because individual. For the statistics, that doesn't work for each individual, right? It's only work for a large population. I don't know if you guys have those reports or not. They say the condoms usually effective in 95% of chances, right? So 95% of chances, that means, if it's 1,000 people have tested, 950 times it's working, but there's still 50 times it doesn't work, right? 50 times doesn't work, not effective. So that's, it kind of can help you understand, okay, what does those statistics mean, okay? So here is Avastin is the new drug, which is actually called out. Let's see if it's gonna work. They have the Congress hearings talking about those people. It's still working.
A best-selling cancer drug is under fire as a treatment for breast cancer. An FDA panel of oncology experts voted unanimously that Avastin is ineffective, unsafe, and should have its approval for treating breast cancer withdrawn. That recommendation now goes to the head of the FDA, Margaret Hamburg. She'll make the final decision sometime after July 28th. And that decision will be watched very carefully by people who are using and being helped by Avastin. A man from Troy says he can't sit back and do nothing while his wife fights cancer.
Action News reporter Michael Rosenfield talked to the man who says he'll continue the battle for a medication he says is working.
Just back from suburban Washington, D.C., Terry Calley is vowing to continue the fight to save the cancer drug Avastin for breast cancer patients.
We really have no choice. In order to keep these women alive, we have to do what we have to do, and we will do anything that is legal and ethical and moral to save these women.
Callie's wife Arlene has battled breast cancer for more than 30 years. Eventually it became stage 4 and spread to other parts of her body. The couple, who lives in Troy, believes Avastin has helped reverse some of the cancer.
Thus far, we credit it with keeping her alive. The only way to find out if that would be incorrect would be to take it away, and that would be playing Russian roulette, which is why we need to leave this drug on the market, not only for her, but for the other women.
But the Food and Drug Administration is moving toward removing its approval of Avastin for women with breast cancer, saying there are too many risks. On Wednesday, an advisory panel voted 6-0 to move forward with that decision. The Callies were there to protest with others outside the hearing and to speak to the panel inside. Now it's up to FDA Commissioner Margaret Hamburg, who will have the final call. If the Commissioner rejects Avastin for breast cancer patients, insurance companies will no longer cover the cost, and that could be a death sentence for the thousands of women who depend on the drug but could not afford some $100,000 a year the medication would cost them.
Very wealthy folks can afford $100,000 after tax to pay for medications. For the rest of the folks, that's equivalent to a denial of access. That's equivalent to healthcare rationing.
I'm Michael Rosenfield, Channel 7 Action News.
Now, if the FDA makes it final, Terry Calley.
Alright, so this one just show you a video clip talking about the Avastin and if it's effective in curing the cancers. And they had a Congress hearings, all those things. I saw videos that some of those people using it, some women, is so crying, say, it's so moved that, it's effective to me and I rely on this and all those things, right? But we come out this trials of this about 10,000 patients, right? Looking at this, what they do is that 2.5% of the patients taking this drug had died from a treatment-related cause, compared with 1.7 of the patients who did not take the Avastin. So if they take them, there's more people dying, right? Because those are the side effect. Every drug has side effect. If you're healthy, do not take drugs, okay? So you can see 2.5 and 1.7. Those are really small, right? Really small. But if it's a human life, any statistics even smaller, that counts, okay? That counts. Now, so this is the statistics. They're just showing you take it actually works than you don't take it, right? You don't take it. So that is not effective. Is that effective for that lady showed in the picture? You guys see? Maybe, right? Maybe effective for that individual person. But for a large group of people, it is not effective. Okay? It is not effective. So this statistics can inform us, right? As the consumers, there's a lot of other things, right? Consumers to see, okay, is that good enough, or is it scientific or not scientific? Maybe it's working for that lady, because statistics doesn't cover everybody. It is just the large group of the population. But for FDA, I think they have to cancel it because based on the scientific study, you have to look at it. Now, statistics, here are some of the examples we're going to talk about, right? So you can see in 1960s, the ladies, the hairstyle is kind of pretty much the same, right? Very uniform, the same similar lengths. And then now in 2011, some are short, some are very long, right? But if we just look at the length of the hair, it's more diverse, more variable over there, right? So we want to, sometimes you want to say, hey, how do we quantify it? Just looking at just example, okay? You don't have to study the hair length. You know, maybe people some fashion people were looking at those too. And if if the hair length in these days, the girls want to keep a longer hair or shorter hair.
No.
So you can do a testing, right? So just gonna see using like the average to see how this one compared to the previous ones, right? So that's gonna be a comparison. Now we're going to look at the basic terms, okay? Population, we already discussed, you know it already. Sample, so what is the sample? Sometimes, as I said, we cannot collect a single data for every single individual in that population. We have to take a small subgroup, right? Small subgroup of individual to represent that population. For example, people want to say, hey, what is the height of the boys in University of Hartford? Maybe there's 2,500 students, males here, and you can do it, collect every data, right? Every single one, but that takes too much time, too much energy. But you could just survey a class or two class, right? Just see, okay, I have 50 boys there, and then grab the data, collect it, and then average them. I can get it. Have some good understanding, right? Good understanding. But you don't go to. The problem is that you do not go to athletic center, select 50 people. Why? Huh?
They're gonna be like the same type of people. It's not gonna be like.
What is the problem with that?
It's not a good reflection of all those in the populations.
Right? So it's not a good representation. It's a bias, right? Because the athletic center, you will see those athletes tend to be taller than the average guy. Okay? So you want to do is something, the word we call is a random. You want to randomly select the individual in your in the population to be your sample, right? The sample you're going to collect, it has to be a random sample, okay? Random sample. You cannot just purposely pick all the big ones or purposely pick up the small ones, okay? You want to randomly pick up those things. Distribution. There's different patterns, parametric, non-parametric. Parametric is like a symmetric, okay? Symmetric. And non-parametric means they probably is not, usually is skewed or none, 1p, more than 1p. So basically it's nothing, it's not 1p, not symmetric, so that's non-parametric. Histogram is a graph show you the class, or we can say values, the class or the values versus the frequency, okay? Frequency. So the class, categories, or values, that's the thing you measure, the data you collect. And the frequency is a number, how frequently they occur, okay? How frequently they occur. I'll show you some of the graph here. This is the body length of some organism, 4 to 9, looking at it here. So this is symmetric or not? Not symmetric, so it's a non-parametric, right? Non-parametric. We call it bimodal because it has 2 peaks. But if I cut the left one, I starting from 6. What does this look like?
Wait, you mean like taking off?
Yes, I'm gonna cut this part. You don't see this part. What's the left part? Sorry, right part. Will be symmetric, right? That's gonna be symmetric. And there's other things like the positive skewed and the negative skewed, or you can say skew to the right, skew to the left. Okay, so that means the left side have more data, the right side have more data. Okay. All right, next we're going to talk about some terms. Normal distribution. This is the parametrics, right? Parametric. And this in the middle we call it x bar. Okay, x bar means the average. Okay, the average, the mean. Okay, the mean. You don't have to know the rest of them, but there's some numbers, we call it 95% of values, 99% of the values. What does that mean is just, how much chance, we say confidence level, how much chance that the actually locate the value. You mean your data is located in this range, okay? I'm going to talk more about it, and then you guys can, in the lab, we'll talk about it as well, okay? Statistical terms, so what is the mean? Average of all the values in that sample, okay? In that sample. Just let you know, all the notes is, slides is in Blackboard, okay? You don't have to record every word here, so it's in Blackboard. Median, the value of the middle number when all values are arranged in numeric order. It doesn't matter if it's small to large or large to small, okay? As long as you arrange it in order, the middle number is the median, okay? Is the median. Mode, the value that occur most frequently in the sample, okay? In the sample. So that the most frequently in the sample. Now, tell me, how many hours do you want to study ecology each week? Can anyone tell me? Yes, I just need 5 numbers.
4, 12.
12?
For a week, so like 2 hours a
3.
day.
Okay. All right. I'm gonna write it. Thank you. All right. Anyone else? 5. I need another one. 5. 3. 1 hour. I'm not recorded. All right. Now we have 5 number here. Okay. 5 number here. We have 3, 4, 5, 12. So in this case, so what is the median? I'll arrange it. What is the median here? So the 5 number I got a 4, 5, 12, 3, right? The median is? So first thing you have to arrange it, right? Arrange it numerically. So this is that. I'm gonna put it here. The middle number is 5, right? Position 3. Now, what if we have even number? I have 6 number. What's it gonna be? The average of the 2 middle number. Okay. For example, if I have another one, say 15, then you're gonna do average of those middle numbers. So still 5. Okay. Do average of those 2. Now, what is the mode? 5. Okay, 5. Most frequent, 5. And what is the average? The X bar will be what? The average of all the values, which is 3, 4, 5, 12, divided by the sample size is 5, right? Okay, so you will get 7, 17, 29, and 5, right? No, it's not 29. 7, 11, 29, yes. So let's say close to 6, right? So 6 is your average in this case. 6 is the average in this case. Now, next, we want to, you see there's the mean, median, mode, right? Which one is a good number? So we say, what is this? So mean is, X bar is 6, median is what? 5, and the mode is 5, right? So in this case, they are pretty similar, all 3 of them, right? But sometimes you have to use, if it's symmetric, those numbers should be very close to each other. Mode, median, and the mean. Okay, the three of them should be very close to each other. But what if it's non-symmetric? Which one should we use? Usually, what do we usually use?
If it's skewed.
Yeah, if it's skewed. You think it's a medium, or if it's
Well, the mean would be
medium?
also impacted if it's skewed.
If it's skewed, mean is not a good measurement, okay? Because looking at the large scale. For example, here we say, okay, what is the average household income here? So maybe a number, right? Maybe we have a super rich guy here. So maybe it's every here similar, right? Similar one. But if Bill Gates sit here, right? He walks into this room, and then our average income will be increased dramatically, right? Because everyone added together may be less than his income. See, that's the problem with using mean, okay? With using mean. So you have to use a median. That's going to represent. Doesn't matter. If you count 3 Bill Gates, that's fine too, because the median still did not change much at all. Alright, so a lot of times our goal is to use sample to represent the population, right? The population. So the population size, we use the capital N, sample size using lowercase n, mean, population mean, we say mu, and then sample mean using x bar, just x put the line on top of it, x bar. Variance is the sigma, okay, lowercase sigma. Sigma square, and this one is s square, and then we say standard deviation is sigma and s, and the standard error is se, okay? So what is variance? So we have the variance is showing the spread of the data, okay? Now you can see here, I have 3, 4, 5, 5, so the average is 6, right? But I have another data set is 4, 5, 5, 6, 6. No, that's too small. So if its average is 6, right? Maybe like this. So I have another data set. Some people tell me I want to study 5 hours, 5 hours, 6 hours, 6 hours, 7 hours. Now the average is the same, close to 6, right? But are they different? This one is more what? Variable, more spread of data, right? More spread of data. So you will see if our original one is like this, and then this one may be like this, right? Maybe like this. So it's looking at the spread of the data, how variable, how uniform are those data, right? So the variance is going to measure that. So what is the variance we're measuring? S square we measured as sigma I equal 1 to n. So this is first number to the nth number, means the last number, okay? And it is, can anyone tell me? You guys learn on Wednesday. What should I write? xi minus x bar square. So we have a deviance, right? And then deviance square, then divided by m minus 1, okay? So that's our s squared. So what is s? Square root of s squared, variance. So that's standard deviation. The same, okay? The meaning for s square and the S is the same, meaning is the same, number is different. It's looking at the spread of the data, the uniform variable of the data. Next, we want looking at the standard error. What is the standard error going to tell us? We use the calculation, standard deviation divided by square root of sample size. Okay? So that will give us the, and so sometimes you will see a data say, hey, the boy's height here in University of Harvard I get from my sample is 1.75 meters, right? Plus minus 1 standard deviation. Usually people write down here, okay, now you have 1.75 plus minus 1 standard deviation, which was a let's say 0.225, okay? Just give you an example. If you see this, a lot of times it will show as standard errors. This case, people will see, oh, how spread is the data? If you get another data, you say, I got 1.75, but I got another one is like 0.62, right? That will tell us what? This one and compare this one. What do we see the difference? The average is the same.
There's more error in the one that's 0.62 and the one that's 0.25.
The standard error is bigger, right? It doesn't mean it's an error. It just means that
there's more variability in one of the data than the other.
yes, so more variability. So this one, there's small numbers, large numbers with a big range of data. But this one is a smaller range. Okay? It's not error. Maybe it has errors when you do the measurement, but not necessarily. All right. Now let's give you an example. When we're looking at the data we have here, S square variance for our sample we have here. What is the variance? Please let me know. Just tell me. Say it. Xi, x1 is minus 6. X2 5 minus 6 square plus Does everyone follow me so far? Yes? And divide by 5 minus 1. All good so far? Yes? Okay, next. So we're going to get a number, right? Okay, 3, 9 plus 4 plus 1 plus 1 plus 36 and divide by 4. Then we get, what is this? 10, 15, 51, right? And we get 1, almost 3, right? So what you will get, the variance is 13, right? What do we get is 13. And then we're going to do S. What is 13? What is S? Square root of 13, right? It's something 3. Anybody wants to use a calculator? 3.3 square root of 13.
3.60.
All right. 3.6. That's good enough. All right. Then what we do next is standard error. What is this? S divided by square root of n is 3.6 divided by, right? So you will get a number. I think it's a 1.2 something. So let's do that. Okay. What is that? 1.5? right? So if you use a calculator, you can use it. This one should be 2.25. Okay, 1.6.
Well, the entire room pools 1.6.
Okay, so now, thank you. You have all this here, right? So make sure you understand the process, how we actually collect it, right? Calculate this, right? This is going to be good for your experiment. We can repeat it. We're going to give you another example on Tuesday, so we can kind of repeat it, but make sure you guys can practice as well. Now, this one, the last one is confidence interval. The confidence interval is a calculation. Just the x bar is a range, small and larger. Small is x bar 1.96 multiply SE and minus this. Okay, that one is added.